So here's some ideas worth learning about the nature of science. And some of you may object harshly to some of these. That's okay. I encourage you to sign up for an email or email me, which I'll have a handout in a little bit, and ask me questions about this. I can give you literature or other things, or I can just explain it via email. I love having conversations with other teachers past the conference. I think we too often come here and do all our PLC when we could actually extend that PLC beyond these conference walls. So scientists do not follow scientific method. To think that every scientist follows those 6 or 7 steps, in fact, in some classrooms it has 6 steps, in some classrooms it has 9, and in some classrooms it has 8. There's not one scientific method. There are rational or logical ways of approaching problems, but to say all scientists do it the same way is irrational. Experimental versus observational science. We run into trouble here because when most kids think about science, they think of labs, like doing test tubes and beakers and things like that, and doing experiments. But then you have guys like Galileo and Einstein and Darwin who never did experiments. They observed the natural world and tried to make sense of the data. Scientists work collaboratively. A lot of times we have kids working together in class, but they still see scientists as working by themselves. They're students, not scientists, and so they don't make that connection unless we help them make that connection. Theories do not become laws, ever. I'm not going to get into that one. That's actually a pretty complex idea. Science requires creativity and imagination. We leave that out. We know we want our kids to use creativity and imagination. We know that they are using creativity and imagination, but we never let them in on that secret. That, hey, guess what? Scientists do this too. Science ideas can change, which goes back to the Rutherford example. Over time, those ideas have changed, and most of our ideas have changed over time, whether it's refinement or revolution. Tentativeness or change is a constant thing in science. Culture affects science. Science and technology are related, but they're not the same. I would argue that there are very few scientists left in the world. Because of our governments and things like that, everybody has to become a technologist, because if there's no practical application, it's not going to get funded. And that's sad. That's unfortunate. Science does not use supernatural explanations, which goes back to the popsicle stick. None of you wanted to use supernatural explanations. You take your car to the mechanic, and he says it's possessed by a demon, you're going to find a new mechanic, not hire a priest. Scientists are biased, which we always tell scientists, we always tell students that science is supposed to be objective. Yeah, they're supposed to be, but it's not actually possible. Science takes time, and that goes back to that eureka moment versus hundreds of years to figure something out. So why nature of science? Oh, that looks familiar. Improved understanding of science concepts. Citizenship and cultural literacy, that's a little bit different. That's a new one. And that goes back to the funding. Like if you know nothing about science, but you might be in charge of a funding agency, you need to understand there's a difference between science and technology. Increased interest in science. And this is kind of the one that kind of sticks with most people. You are teaching the nature of science anyway. When you give the students a cookbook lab that's step by step, you are sending a very powerful message about science. You're making it seem like that's what scientists do. And I'm not saying don't do cookbooks. So there's a time and a place for cookbooks, like when safety concerns or students don't have the background knowledge, things like that. But when you do that cookbook lab, the 5-minute conversation should be, how is this not like real science? And that's it. And at least then you're explaining to students. And maybe, with more advanced students, you could even ask them, why do I do it this way, instead of having you do it more like real science? All right, now to the example, which I don't know if I'm going to have enough of these. I think I only have 25. So if you can share, please do. And what I'm going to have you do is I'm going to have you read the inside page. So like the back of the first page, read that story, please. I will